Hello everyone, this is the end of section 2.6 and we are going to talk about even and oddness of functions. So how to tell if a function is even or odd, and I will do it a couple of different ways. We'll talk about if you have a function given in its formula form, or if it's a graph, what it kind of will look like if it's an even function or if it's an odd function. But first of all, what in the world does it mean? So I do have the definitions written here. So we first of all have to be a function. So again, if you can remember, a function is something that passes that vertical line test. For every input, for every x value, you only get one y value coming out. And if we do have a function is considered to be even. And there is some connection to those terms as far as exponents go, but we do have to be a little bit careful. So we'll talk about that in a second. But an even function, if f of negative x, or the opposite of x, is the same as f of x for all x's in your domain. So first of all, if the number 3 is in the domain, -3 also has to be in that domain. So we're not going to see lots of holes showing up in these functions. An odd function, if you have the opposite of x, you're actually going to have the opposite of the value. So for all the values in x. So you're thinking to yourself, what in the world does that mean? So a picture. So let's look at the even idea first of all. And let's say we have some value x. So here's an x value. And let's just arbitrarily pick its y value. And I'm going to put it down here. And maybe we'll do another, we'll call this x2. So there's x1 and x2. If x1 is in the domain, the opposite of it is also in the domain. So here is the opposite of x1. And the opposite of x2 would be in here too. Okay, so if you want to give numbers to it, 1 and 2, -1 and 2 would be in there. And they're going to have the same y value. So if this is your y value here, this is going to be the same y value on this side. The y value here is going to have the same y value. So no matter what your y values are for positive x values, those negative x values have the same y value. So if you're thinking picture-wise, this side is going to be a mirror image of this side, or it is going to be reflective along that y-axis. Okay, so we have that mirror image going on along this y-axis. So that's an even function. So we'll have that symmetric. Maybe that's a better word. Symmetric along the y-axis. Okay. If we are an odd function, so here's my x1 and my x2, and I'll give them the same y values that I did here. Now the negatives will also be in there, so negative x1 and a negative x2. So they first of all have to exist, but now you'll notice that the y values will be of opposite sign. If this was a positive, this one's got to be a negative. If this was a negative, it's going to be a positive. So it's going to flip. Well, these are drawn really hard to see, so maybe I should put some more in here. So let's put 0 in there. So we have this thing going on. So it's going to be flipping and look a little bit that way. This is said to be reflected along the origin, because it's got to go from here across the origin to the other side. From here across that origin to the other side. Or it is symmetric with respect to the origin. Some people like to think you take this piece here and you flip it up and you turn it and put it back down. I don't know if you can visualize that. So if you're looking at graphs, that's what you're going to see. So if I had something like this here, it's going to be reflected and look like that. So think about all those wonderful art things you used to do way back in grade school, where you'd paint one side, you'd fold the page open, and you'd peel it back out. That's what you'd get here. This one's a little harder. You'd have to paint one side, pick it up, rotate it, and put it back down. A little bit more difficult to see. Looking at formulas, determining if it's even or odd, requires a little bit of work. There is something, though, I want to make sure to mention, is not every function is even or odd. We could be neither, and there's just as many even functions as there are odd functions as there are neither functions. So we don't have two categories, because it could fall into neither one of those, and we would say it's neither even nor odd. So let's see. And we're going to ask ourselves, are these functions even, odd, or neither? Okay, so let's look at f of x equaling x squared. I'm going to start with something simple. Now we've seen this graph, and if you know what the graph looks like, it looks like our u, it's our parabola, centered with that vertex at 0, 0. Those terms will come into play later in the semester, but it is that little U shape. And if you look at it, you will see it is pretty symmetric about that y-axis. So we're thinking it's even. I also see an even exponent, and yes, that's where the term even came from. But to check, what I'm going to do is I'm going to substitute the opposite of x in for my function and see what happens. And now we know that if you take the opposite of x and we square it, we get the same thing. We get x squared. So notice if I put the negative x in, I end up with what I started with. So this thing is even. So you're going to compare what happens when you substitute a negative x in for x. Do we end up with the exact same thing? Then we have an even function. If we end up with the opposite, the negative of what we started with, then we have an odd function. If our signs are off, we will have neither. So here's a even function. I'll do a function that looks like it should be odd. So there's my x cubed function. If I substitute that negative x in, so that's going to be a negative x cubed, and thinking the negative times a negative times a negative is a negative x cubed. We're getting the opposite of what we started with. We have thus an odd function. Let's look at another one. So let's look at h, and let's let that one be, I don't know, 4x to the third minus 2x. Okay, and I'm going to find out, is it odd, even, or neither, or even, odd, neither, whichever order you want. But to do so, we're going to substitute in that negative x and see what happens. Okay, I can factor this negative out because a negative times a negative is a negative. So this turns into negative 4x cubed. Here I'll have a negative and a negative, which is plus 2x. To force you to see that it is the opposite of what I started with, I'm going to pull a negative out of the whole thing. And you'll see that it is the opposite of what we started with. This one is odd. And in fact, if you have all odd exponents like we do here, it will be an odd function. If you have all even functions added together or subtracted, it will be an even function. If you have a mixture, which I'll do this time, we'll just do x cubed plus x squared. So there's a mixture of powers. We'll find that it's going to turn out to be neither. So I'm going to cube my negative. I'm going to square my piece. This turns into negative x cubed plus x squared. It is not the opposite of what I started with, nor is it the same thing that I started with. So this is neither. So hopefully you can tell by either checking with the formulas, substituting in that negative and seeing what happens, or by looking at the graph. If it's symmetric with respect to the y-axis, that folding mirror image along that y-axis, it is even. And I keep a couple examples in my head to kind of help me. I think of x squared, so I can picture x squared, that nice symmetric about that y-axis. X squared is an even exponent. X cubed is the one that looks like this. Okay, this one is an odd function, so it's nice to pick this guy up, rotate, put it down. So that is my even function. Your absolute value function will fall into that even category. Your square root function is a neither, because we can't take the square roots of those negative or those opposite values. So that is a neither function. So we have lots of concrete examples of everything we know. So most of your straight lines are going to fall into that neither category, because if you have a straight line, there's a straight line. This will be a neither, because it is not reflected and it does not rotate down either. So this would be a neither. It would have to go through 0, 0 to possibly be odd. And there's only any horizontal line would be considered a even function. So hopefully this is a nice little introduction to what even and oddness is and how to find it by looking at graphs or by looking at those formulas.